Method of computing the square. In your textbook, you're given the example 2x squared plus 7x plus 6. Now, when doing the method of computing the square, what you want to do is get rid of any leading terms. Here, our leading coefficient here that we want to get rid of is this 2. So what do? We factor it out. We have 2 out of the bracket, and inside the bracket, what's left is x squared plus 7 over 2x plus 3. Now, I'm going to ignore this 2 for a little while and focus mostly on what's inside the brackets over here. And I notice that if I have x plus 7 over 4 squared, what happens when I when I multiply this bracket with itself and expand, is I get x squared plus 2 times 7 over 4x plus 7 over 4 squared. And simplifying this gives me x squared plus 7 over 2x plus 49 over 16. Now I notice from that uh, this over here, the x squared plus a 7x plus a 7 over 2x resembles this over here. That's perfect. I like that. But there's an extra term. There's the plus 49 over 16 over here, which does not match with my plus 3 on the left-hand side here. So what I need to do to make my x plus 7 over 4 squared over here equal to what's over there is I need to, first of all, subtract this extra 49 over 16 and then add the 3 that's missing. So if I were to rewrite this, so if I were to make uh, the left-hand side here equal to the right-hand side, I would need to write this is equal to 2 times, and then I have x plus 7 over 4 squared minus the 49 over 16 plus 3. So I subtracted the 49 over 16 because I know that when I expand the x plus 7 over 4 squared, when I expand it, I get a positive 49 over 16. So that's why I'm subtracting it, because I want to get rid of it. And then once I get rid of it, I still need to add this 3 that's missing, so I added plus 3 here. And of course, all of this is inside bigger brackets, and all of it is multiplied by 2 because I have this leading 2 here. Now I'm going to simplify the inside this bracket, so I have 2 times x plus 7 over 4 squared minus 49 over 16 plus, and now multiplying top and bottom by 16, because really what I have here is 3 over 1. Multiplying top and bottom by 16 to get a common denominator gives me 48 over 16. Doing subtraction gives me 2 times x minus 7 over 4 squared minus 1 over 16. Alright, almost done. This is really just 2 times x minus 7 over 4 squared minus 1 over 4, all of it squared. So what I did here is I noticed that 1 is a square and 16 is a square. It's 4 squared. So I wrote 1 over 4 and I squared everything because when I distribute the 2 back into the bracket, I square the top and the bottom, which gives me 1 over 16. Now, almost done. I noticed that inside the bracket what I have is the difference of 2 squares. So that means that I can now apply the rule I know for difference of 2 squares. So this gives me 2 times the first thing plus so x minus 7 over 4 plus 1 over 4. That's my first term times the first thing x minus 7 over 4 minus 1 over 4. So it's first plus second, first minus second term. Now simplifying this gives me 2 times x 7 over 4 minus, 7 over 4, negative 7 over 4 plus 1 over 4 is negative times x minus 7 over 4 minus 1 over 4 is minus 8 over 4, which is just 2. So now that I've simplified all this, I don't actually need the big square brackets over here. So I'm going to get rid of them. Let's get rid of this. I don't need this. And let's get rid of this. I don't actually need it. The 2 is still multiplying. So what I can do now is I can multiply this 2 into this bracket if I wanted to, and I distribute it everywhere inside this bracket. Just the first bracket, not the second one, because the 2 associates with the first bracket here. What I'm left with is 2x minus, um, so 2 times 6, 12 divided by 4, 3. And then the second bracket, x minus 2. So here it is. I've just factored 2x squared plus 7x plus 6 using the method of completing the squares. It's a long, sometimes complicated method, but it works. And here's the final result over here.